Hi everyone. So today we're going to talk about modeling tax schedules. So we're kind of going to take a look at these tax charts and tables that we looked at yesterday and model it using some algebra. So we're still going to use some inequality concepts that we talked about the other day, and we're going to introduce the y equals mx plus b form. So let's take a look at what we have. So today we're going to construct some tax graphs using compounding equations. So again, we have some terms. So we have flat tax or proportional tax. This is tax where the percentage remains the same no matter what the price of the item you purchased. So this would be, an example of this would be when you go out and buy things and that's taxable. So in Pennsylvania, we pay 6% tax on goods. So that would be when you buy a shirt. Not a shirt. And there's sales tax. Okay, and it doesn't matter the cost of the shirt. So you can buy a $10 shirt or you can buy a $50 shirt. You're still paying 6% tax. That's called a flat tax or proportional tax. Now, progressive tax system is when it increases as your income increases. So if you make $50,000, you may pay 5%. But if you make $100,000, you may have to pay 10%. Okay, so as your income goes up, your amount of tax goes up, and that's what we have here in our chart. So you have what is called the income bracket or tax bracket. Each line of the tax schedule has a different percentage. So if I'm making between $18,450 and $74,900, if you notice, my percent is only 15. But if I make between $411,500 and $464,850, my percentage is now 35%. So as my tax increases, my percentage that I pay increases. Now there is a movement out there to change that, and that's called a regressive tax schedule. So in other words, is instead of having as you increase your amount, you increase your percent, it goes the other way. That your tax rate decreases as your income increases. That's in this discussion. That's not what we do right now. Okay, so let's take a look at this schedule. And we're going to model using tax schedule, interval notation, and compounding equation interval notation. So I already have some started for us. And then we did this a little bit yesterday with the inequalities, but now we're going to put it in with all three different forms. So you have the words, you have the word and you have the interval. So one of the things you have to remember is that compound is and. This is a between, which is the interval. That's when the X goes in between your two numbers. And the tax schedule is the words. Okay? So if you look at the first one, it says over $0, but not over $18,450. And then you have X is greater than 0 and X is less than or equal to $18,450. And 0 is less than X, which is less than or equal to $18,450. So that's what we want to do. So I already did the second line. So this is the line we're on. Okay. But again, we're only interested in this first section. So now I'm going to write it with the word and. So 18,450. Let me do that again. I forgot the X. X is greater than 18,450. And X is less than or equal to 74,900. Okay, so let me move that into the box there. Okay, now we're going to do the other one, which is where it's in between. So 18,450 is less than X, which is less than or equal to 74,900. Okay, let's try the next one. All right, so here I give you the one with the and. So I think it's probably easier. Let's do the words first. So we are over 74,900. but not over 151,200. Okay. All right, let's try it with the between idea. So 74,900 less than X, less than or equal to 151,200. All right, let's just do one more. So I gave you the between here. Okay, so we're going to want to be less than the 151,200 and X is going to be less than or equal to 230,450. Okay, and then let's do it in words. So we're over 151,200, but not over $230,450. Okay, why don't you pause the video, take a moment. I left the last two lines blank. Okay, so you're going to be doing this interval and then this interval, and let's see how we do. Okay, let's see what I came up with. So I have over 411,500, but not over 464,850. So we have X is less than 411,500 and X is greater than 464,850. And then we have the between 411,500 less than X less than or equal to 464,850. Okay, now the last one is a little tricky because it doesn't have an ending one. So we're just going to go over 464,850. So this is only going to have one inequality. X is greater than 464,850. And then again, X is greater than 464,850. Okay. All right, so let's try this one. So we're going to pick the right tax bracket for this. We want to know which inequality, which set would be 172,876. So we got to figure out which interval that we just wrote is where this is going to land. So let's take a look. 74,900, 151. Oh, I do believe it's going to be in this one. Okay, so that's what we're going to write. It does ask for all three. So the first one would be over 151,200, but not over 230,450. Okay, so X is less than 151,200. Oh, sorry, greater than. Why did I have less thans there? These are greater thans, and the other one is less than. I apologize, guys. Should be greater than. And X is less than or equal to 230,450. And then the interval notation, 151,200 is less than X, which is less than or equal to 230,450. Okay. All right, so that's all we're doing for that. Now, we can take this information and apply it to tax equations. So if we look at this particular chart up here, this schedule, and we had, like when we did this the other day, we took the number, added 15% of the difference between these two. And we found that to be a little confusing, and we did a worksheet, a work column on this, okay, which is down here. And we found that to be easier. And then the question was, where did this 8,412 come from in this little worksheet section? Well, it comes from creating an equation. Okay, so this is going to be an equation that we're going to be using. So it's basically saying we're going to take 10% between 0 and 18,450. Let's write an equation for that. And that's what we do. So if it's between 0 and 18,450, we're 10% of whatever your value is. So X's represent your income. And then it keeps going, so over 18,450, but not over 74,900. They give you this number, and then times plus 15% of the difference. Okay, so those are tax equations, which means that we can write them with y equals or f of x equals. So this is just another way to say y equals, and this is telling you what numbers can go in for x. So the only numbers that we can put in for x are between 0 and 18,450 are going to go in for x in that equation. The minute we get above 18,450, we go to the next equation. So if I'm above 151,200, but below 230,450, this is the equation that I'm using, which is the same equation we found in our tax schedule, okay? Which is where these numbers right here in our worksheet section all come from. Watch what happens. So if I have this equation, which is for the numbers between 74,900 and 151,200, this is the equation that comes from here that I would use. But I don't know the x value. So basically, I'm just going to simplify this. So I'm going to take the $10,312.50 plus, and then I'm going to distribute the 0.25x. Okay, so I'm going to basically just distribute that and get 0.25x minus 18,725. Okay, then I'm going to combine like terms, which means I'm going to take this 18,000 or the 10,312.50 and subtract 18,725. And so I'm going to get 0.25x minus $8,412.50. Now, if we look at that last number and I come back up to that worksheet part, this number, okay, this 8,412 is that number right there. Okay, so that's where these numbers are coming from. They're coming from the distributive property when we rate the equation. And if you notice, this form is in y equals mx plus b. Oh, that means something for us, which means it's a line. So that's going to be important. So let's take a look at what it does for us. Okay. So we have a tax equation for over 230,450, but not over 411,500. Is y equals 51,575.50 plus 0.33 or 33% x times the quantity 230,450. Okay, so let's clean this up. So we get 51,577.50 plus 0.33x minus, okay, okay, 0.33 times 230,450. I get $76,048.50. And I'm going to subtract that from the 51,000 that we have there. So we get y equals 0.33x minus $24,471. And nope, no 50 cents. Okay, so what exactly does that mean? Well, that means that we're going to, the slope, which is 0.33, is what we multiply the amount by. The income by. And the y-intercept, which is that negative 24,471, is the subtracted amount. Okay. All right, so take a minute or two and let's express these forms in y equals mx plus b. All right, so the first one's going to stay the same because there's no distributive property. So we're going to get y equals 1,845 minus 0.15x minus 1,845 times 18,450 minus $34,004. I believe 25 cents. And then, nope, that's not right. Entered it in my calculator wrong. So let's try that again. 1,845 minus times. Not doing good today, guys. 0.15 times 18,450. I get 2,767.50, and then I'm going to do 1,845 minus 2,767.50. Okay, so this is negative 922.50. Okay, so y equals negative 0.15x. Okay? All right, so we get the idea. We're going to distribute and then clean up. And again, what does that slope tell us? Okay, plus that the slope is the percentage that we're going to multiply by, and then that 922.50 is what we're subtracting from that multiplication. All right, so let's make sure we use the appropriate equation from what we did up here to determine a tax for income of $46,000. So 46,000, let's go all the way up. Here we go. So 46,000 is going to put me in this bracket. So that's the equation I just did. So we're going to come up with y equals 0.15x minus $922.50. Okay. All right, so hopefully that's not too bad. Let's take a look at this last thing. We're going to talk about how are we going to take these equations and draw a graph now. Now, these graphs, because it's in sections, we call them piecewise functions. Don't get hung up on the name. It just says that we have for different x's, we have different equations, and we're all going to patch them on the graph. All right, so what we're going to do is for values that are between 0 and 18,450, we're going to use that. So I'm basically going to come down here to my graph. Now I went by 10,000s down here. So this is 10,000, this is 20,000. So 20,000 would be, the 18,450 would be before that. So I just made a little mark there. And I'm going to basically go by my slope of 0.1, which means up 1 over 10. So up 1 over 10 is going to be really small. Okay. And there's my graph. Okay. Now, when I get to 74,900, which is the second one, which is 80, 90, 80, 70, right here. Okay. That's going to be a little bit steeper. And then the last one has a 20, 15, 1150, somewhere in here. Has a much steeper graph, steeper slope. So we're going to be almost up to 30,000. So it's going to be up here. Okay. All right, so we have a much steeper slope. So each section is going to increase their slope. All right. Now, I didn't give you any graphs for tonight. I just wanted you to take a look at it and see what it would look like, but they're basically connected lines. All right, so remember what we did today was writing in inequalities in words with the word and with the inequality symbols, and then take those equations, distribute, and write n equals y equals mx plus b form. Okay, have any questions, please let me know. Stay safe and have a great day.